So I first started off with part E, and so the first thing that was added was heat. So heat was added. So it was an exothermic reaction, and exothermic reactions happen on the product side. So that meant to put it back to equilibrium, it would have had to shift left, decreasing the concentration of this molecule right here. So this would be the brown molecule, except it lightens up because there's going to be less concentration of it. And then right here, so this molecule was added. So that meant it was added on the product side. And so when it's added on the product side, it has to shift right for it to return back to equilibrium. And this was proven when this molecule, when the solution turned dark brown, because this molecule's concentration would be increased. And same with this one, except it was a different molecule or a compound, and it would have the same effect with shifting right, and it had also the same observation. And then this one, it would be a shift left because a precipitate was formed, so that meant Q equilibrium had to be bigger than K equilibrium for that shift left to occur, and this was observed when a precipitate was formed. And then for part F, so part F was the saturated sodium bicarbonate plus HCl. And so HCl was added on the product side, so it meant it had to shift right for it to return back to the normal. And observations that prove this is because this concentration had to increase to compensate for more molecules being on this side. So the concentration of here had to increase, and that's why there's more bubbles formed. And then for aspiration, it had a shift left because right here was decreasing because aspiration removes all gases, and CO2 is a gas. So when this was decreasing, it had to shift left to return back to equilibrium. So that's why bubbles were decreased, and that's why it also returned back to the coloring of which it was before. So for this one, the original pH was 4, and then it turned to 5 when the ion was added. So that would be a shift left because the pH, because H was consumed, because we know this because it became less acidic, so it went closer to 7. So when it becomes less acidic, it basically means a molecule or H plus is consumed. So that's why I had a shift left to make up for the lack of H plus.